guys, thanks for tuning in. Is that what you say when you make a video? So we are going to start with 9.4, which is dilations. So the last lesson we did, which I know was a whole long time ago, was we did reflections. And remember, if you're reflecting over the x-axis, then the y unit changes. And if you're reflecting over the y-axis, the x unit changes. So today what we're doing is dilations. What that means is if I have a point, which we know is x and y, dilating means that we are either going to make that image bigger or we're going to make it smaller. Kind of like when you go to the eye doctor and you dilate your eyes, they put the stuff in and it makes your pupils really big or they make your pupils small. So we're going to be doing the same thing with images. So if I have a point, let's say it's 2, 4, and I dilate using something like that. What that means is I'm going to multiply the x by 3 and then the y by 3. So I have this, my new point would then become 6 because I multiply it by 3, multiply that by 3, so it would be 6, 12. Okay, so this is dilating a point, and then if we work with images, let's go ahead and create an image. So if I make your x and y axis, we are going to create an image. So let's say I'm going to do my first one in blue, and I'm going to make points here. I'm going to go ahead and make it a rectangle, and my points are -6, 2. I'm going to make this A, B, C, and D. A is going to be -6, 2. B would be -2, 2. C would be -2, -1. And then D would be -6, -1. So if I were to dilate this and I use that same, I'm going to use the same dilation as what we used before, where I create 3x, 3y. That means I'm going to multiply each of those points by 3. So this -6 times 3, this -6 times 3 would be a -18. Ooh, that's really big. Let's go ahead and we'll change this to 2x and 2y. Then that way you can actually see what we're graphing. So this would be a -12. So my dilation would be -12. 4. My dilation for B would be -2 times 2 is a -4. 4. My dilation for C would be -2 times 2 is a -4. And then -1 times 2 is a -2. And we'll do the same thing for each of the points. So D times -2 is going to be -12. -1 times 2 is going to be -2. So there's our points for our dilation. And we should be able to go ahead and graph that. So I'm going to go 2, 4, 6, 8, 10, -2. I'm sorry, -12 up 4. So that's my dilation for A. B, I'm going to go -4 up 4. There it is. C is a -4, -2. D is going to be a -12, -2. Now I have a dilation for each of the 4 points, and I can show it's going to look the same, and what we just created was a similar figure. We want to put them on the same coordinate plane, so you have the original and you have the copy. Now you can do this in 2 different colors. I did it in 2 different colors so that you can see the difference, but you don't have to. You can do them as long as you label which one is the dilation with a little comma or apostrophe so that you can see the difference. You'll be able to do that. So it does not matter if you have colored pencils or different colors to create them. So this is a dilation making it larger. If I had made it smaller, let's go ahead and we'll work with just the points just so that you can see. I think we understand how to graph, but let's say I and I had 2 is my point, and I'm going to use the dilation scale saying that I do 1/2 of x and 1/2 of y. So this is a little bit different. Again, we're still multiplying, but when you multiply by a fraction, you're dividing by the reciprocal, or dividing is the same thing as multiplying by the reciprocal. So all I'm doing when I take half of 14 is I'm gonna make my dilation here 7, and then half of 2 is 1. So there's the dilation if I were to use a fraction as opposed to a larger number. So that means if I have a fraction here, my image of the dilation is actually going to be smaller than the original. If I have a whole number here, then that means that my dilation will be bigger, okay? So that in a nutshell is dilations. You should be able to do what you need to for this. So your assignment for lesson 9.4 is going to be, I'm going to have you do just this first section, which is just numbers 4 through 11. And I'm gonna have you do all of them, numbers 4 through 11. Now, our lessons when we do this are gonna be a little bit shorter than what we would normally do if we were here. But then that way you can still show me that you're understanding what you're doing. You can still ask questions and you get the general idea. So this is all on page 537, okay? Numbers 4 through 11, page 537. That is 9.4, that is dilations. Now let's go ahead and move into 9.5. So 9.5 is on scale drawings and models. So I'm going to work with just scales. Now, what that means is when you are looking at a map, when you see distance on a map, that is a scale. So that helps us to understand that you can't actually put like the distance from here to Antioch on real life because there's miles there. So we create, like when you're doing your history maps and that type of stuff, you have a scale there that says, okay, 1 inch equals 10 miles. So if I were doing something like that, where 1 inch equals, what did I say, 10 miles? If I were to look at a map and I say on a map, the distance is 2 inches, in real life, what would that be? So we create a scale. So I put inches over miles, and this is using those common proportions that we've used before. So we have inches, I know it's 1 to 10 miles, and then I know 2 inches is what I've been given. So what is it in real life? That's gonna be like an X. And then we use our cross multiplying, or for this, you can probably see it. I know that 1 times 2 equals 2. So 10 times 2 would equal 20. Okay, so in real life, it'd be 20 miles. Okay, make sure that you label your answers. So we should have all of the above. Let's go ahead and look at your book. If you have that with you, we can look at page 541. So on that, it says that the scale that they give us is 1 inch equals 60 miles. 1 inch equals 60 miles on the map. So if we're looking at the map, and that one gives me 2.5 inches, okay? So I go ahead and say, okay, 2.5 inches, where am I gonna put that? Let's create a common proportion. Again, I put inches over miles. So I'd have 1 to 60. 1 is my inches, because that's what I have here. 60 is my miles. Now when I have 2.5 inches, that's gonna go on top, because my inches are on top. So I'd go ahead and do that. I don't know what that is. And again, you may be able to figure this up off the top of your head, that's fine. If not, use your calculator, your handy dandy little device. I can't talk, it's fine. So 2.5 times 60 is going to give me, X would equal 150 miles. So how far is it in real life? It's 150 miles. If on the map 1 inch equals 60 miles, 2.5 inches is gonna be 150 miles. And this will help you when you're doing your history worksheets and that type of stuff. Now let's say we look at page 542. So on the bottom there's an example of this strawberry sculpture. No, It shows a fake strawberry on the top of a street sign, and it's huge. Obviously, that's not a real life strawberry, okay? So in real life, it shows that it is 180 inches tall. That is not reality. You cannot have a strawberry that is 180 inches tall. But we know that the conversion is 120 to 1. Okay. Now they don't give us any measurements. If they don't give us, whoops, the daisy. If they don't give us any measurements there, what we're gonna assume is that it's all the same measurement. So 180 inches is in real life. This scale of 120 to 1 means 120 inches in reality is 1 inch, okay? So if we say the image or the false thing over reality, that's what we're gonna do. So our image here is the 120, the reality is 1. So we'd go 120 to 1. Now, what they gave us was the actual image, which is the 180 inches of that strawberry that was created. That's gonna go here. And then the actual strawberry that they used to model this off of is gonna be our X. So we go 180 divided by 120 will give us that reality. So we have 180 divided by 120. Again, you could use your calculator. You should get, if we simplify it, what do we have? 18 over 120, or 18 over 12. We could then divide by 6, so I get 3 over 2. Now, I can't give a measurement of something like that. So it is real life, so I'd actually want to say 1.5. Because it's measurements and stuff, I could say 1.5, or I could say 1.5 inches is the strawberry that they used to model to create that huge image, okay? So I hope that helps a little bit. I know these are kind of the same type of lesson, so that's why we're merging them together. Your assignment then for 9.5 is gonna be 3 through 16 all, okay? So 9.5, go ahead and make that darker so you can see it a little bit better. 9.5 is numbers 3 through 16 all, and that's gonna be on page 543. So hopefully that helps. I know that you guys might have questions. If you do, ask. Post them in the classroom. I'm gonna post this YouTube video. I'll put it in the classroom and I'll send it to your parents just so you have information for both of these lessons. Again, if you have questions, ask. I can help you on the classroom, or you can send me pictures when you're doing your work and you have no idea what's going on. I will respond as quick as possible, okay? Hope you guys are doing well. I know you miss me tons and that it's really hard to get through life without me, but you will survive, okay?